All right, so 6.4, we're going to be talking about rational exponents. And if you remember, a rational number is a number that you can write as a fraction. Okay, so what's going to happen here is our exponents are going to be fractions instead of having a radical symbol. So an example of this, the square root of 25 can also be written as 25 to the 1/2 power. Okay, so this is your power now. Or if I said the cube root of x, you could also write that as x to the 1/3 power. Here's how we do it. This is like 25 to the 1st power, and we're taking a square root of it. So you always do the power divided by the root or the index. The way I tell people to try to remember that is your power goes on top, right? If you are a person of power, you are on top of the world. Your root, the number outside here, goes on bottom because roots grow down, right? Roots go to the bottom. So that's how I try to tell people to remember it. It's up to you if that's how you want to think about it. But we would take the 2 and put it on top, and we take the root or the index and put it on bottom. Okay, so the reverse of that, if you want to think of this in reverse, if they give you the exponent as a fraction, right, a rational exponent, what you're going to do is just kind of reverse that. So 125 to the 1/3 power is 125 to the 1st power, and we are cube rooting it, okay? The cube root of 125 is 5. So 125 to the 1/3 power is just 5, okay? Letter B here. Now there's 2 ways that you can think about this one. It's up to you which one you like better. You may do either one. But 5 to the 1/2 power is like saying the square root, that's the 2, right? There's essentially a little 2 there. The square root of 5 to the 1st. So you could say the square root of 5 times the square root of 5 is the square root of 25, which is 5. Okay, so 5 to the 1/2 times 5 to the 1/2 is 5. If you would rather do a different method, here's what you can do. Remember what we said, when your base is the same, so they're both a 5, then what you do with your exponents is you add them together. So this is basically saying you could think of it as 5 to the 1/2 plus 1/2. Well, 5 to the 1/2 plus 1/2 is 5 to the 1st, and 5 to the 1st is just 5. So you'll get there either way. It's more just a matter of what do you like. But if it's the same base like that, you're allowed to add these. Okay, now look at this one. Not the same base. It's the same exponent, but it's not the same base. So you cannot add these because you have different bases. But you can convert it to radicals and then simplify from there. So 10 to the 1/3 power, this is your root, right? So it's a 3rd root, it's a cube root of 10 to the 1st times, and then again, it's a cube root of 100 to the 1st. Now this you can simplify because you have cube roots of both. You're allowed to multiply what's inside. So that's going to be a cube root of 10 times 100, or 1,000. And the cube root of 1,000, at this point, if you want to plug it into your calculator, remember that's math 4, and then you just type in 1,000, and it will give you 10. Okay, so the cube root of 1,000 equals 10. Okay, so now we're going to work with some fractions that aren't quite so, your numerator is not going to be 1 all the time, okay? So let's think of it like this. You have 2 ways that you can think of this setup. 25 to the 3/2 power is basically saying 25 to the 3rd power, right? The power is on top, and then you can square root that, or do it in the other order. You can square root it first and then take it to the third power. It's up to you which one makes more sense. I think this one for a number like 25 makes a lot more sense to me because I know the square root of 25 is 5, and I know that 5 to the third power is 125. Whereas if I did it this way, I'm going to get a really big number that I then have to square root. So typically, this way is easier. Take the root first and then the exponent, but you can do it either way. Okay, so this is the property. It's what I just showed you here. This is this, but with variables instead. So if I have a to the 1 over n power, that means I'm taking the nth root, right? This goes here, of a to the first power. This number goes here, the power. Okay, so if I have two different numbers, not a 1, now my m and my n, the n is still your root, the m is still your power, so you can write it this way, or you may write it this way. They are the exact same thing, but like I said, typically this way is a little easier. Not always, but most of the time. That's my preferred method. Okay, if you need to pause right here and talk to your neighbor about what I just went through to clarify anything, go right ahead, but otherwise we will keep going. And you can always clarify later once you get going on the homework. Please use your neighbors right now. There are people all around you that know how to do this stuff and know how to do it well and are very helpful and very kind people, and I'm sure they would love to help you. So if you're stuck, ask for help, okay? And you can always email me anytime, and I will try to get back to you as best I can. Okay, example 2. Now we're going to rewrite in radical form. So they're going to give us the fraction, and we're just going to rewrite it as a radical, okay? Just remember, this is a power. Power goes on top. This is a root, or an index, if you will. Those are the same thing, and those go on bottom. Okay, so if I'm going to rewrite this in radical form, I'm going to write it a fifth root of x to the third power, or you could write it the fifth root of x and take that whole thing to the third power. Either one of those is right. I don't care which one you do. Okay. Okay, now we have this decimal, and you need to think of that as a fraction first. If you're not sure what that is, you can do this in your calculator. Plug in 3.5, and then hit math, and then hit fraction, which is just the number 1 there. 3.5 math fraction, enter, and it will show you that 3.5 is the same as saying 7 over 2. Okay, so y to the 7/2 power. And if you can come up with that on your own, then you don't have to plug it into your calculator. But if you're not sure, plug it into your calculator. It will turn it into a fraction for you. Okay, so if it's y to the 7/2 power, that is a root of 2. So that is a square root of y, and then to the 7th power. Or if you like to write it the other way, you could also write it the square root of y and take that whole thing to the 7th power. Okay. Again, I think this one looks a little nicer. So I would probably write that one this way, but they're both correct. Okay, now we get a little fancier yet. This negative right here changes things a little bit. Remember what we do with negative exponents? If there's a negative exponent, we move it from numerator to denominator or denominator to numerator. So right now, this is a numerator, right? It's like saying this over 1, if you will. So we're going to put a 1 on top, and we're going to move w to the bottom. And now, since we moved it, we take away the negative. So it's w to the 2/3 power, but on bottom. Okay. Then what we do with that is we call it 1 over. It's a power of 2 and a root of 3. So it's the cube root of w squared is how I would write that one. Questions on that? Hopefully your neighbor can help you if you have questions on that. Did you talk to your neighbor? Everybody clear? It's probably dead silent in there right now, huh? Yep, okay. Example 3 then. Okay, we're going to rewrite in exponential form. So now just reversing what we were just doing. So now they're giving us what our answer looked like, and we're going to turn it into what the problem was the last time, okay? So for this first one, this is a square root, right? The root is the bottom. It is a power of 3. So this is going to be a to the power over root 3/2 power. So a to the 3/2 power. Okay, letter B, same thing. Now this one, they did it in the other form where they did the parentheses around the whole thing and then squared it, but it really is the same thing. It's still your base, so in this case B, and then the power over the root. Power goes on top, root goes on bottom, so B to the 2/5 power. Okay. All right, moving on. Like I said before, when we're doing these types of problems, the root first and then the power is typically the easier set of numbers that you will work with on this. It's not always the case, but it's often the case. So that's the way I'm going to typically do these, unless I see something that's like obviously easier a different way. Okay, so letter A here, 32 to the 3/5 power is like saying the 5th root, oh, let's get a pen back. The 5th root of 32, okay? And then we're going to take that number to the 3rd power. So the 5th root of 32, and again, if you want to plug in 5th root 32, you're going to go 5 math 32, right? That's the 5th root of 32. So the 5th root of, no, 5 math, shoot, I don't have my calculator at home with me, you guys. 5 math 4 or 5 math 5? Check that real quick and then ask your neighbor. Someone in the class, tell everyone else which number it is. And it's going to be 5 math and then 4 or 5, I can't remember which one, 32. Okay, so when you plug this portion into your calculator, you will get 2. That's the 5th root of 32. And then we're going to take that to the 3rd power. So 2 to the 3rd power is 8. Okay, I want to see this from you, and I want to see this from you. If you just tell me 8 right here, I'm not going to give you full credit for that. Okay, show me how you would rewrite it, and then you can solve from there. All right. Okay, 27 to the 2/3 power. So this is going to be a cube root, right? The root, cube root of 27. And then once we figure that out, we will square that number. So it's going to be a cube root of 27 is 3. And then we're going to square that 3. So this comes out to 9. Okay, now here's another one of those that has a negative exponent and it has the fraction. So again, you can plug this into your calculator to figure out what that fraction is, negative 2.5, then type in math, then fraction, which is the number 1, and hit enter. And that will tell you that negative 2.5, if you're not sure in your head, is a negative 5/2. So now what we're going to do, because we have that negative, we're going to move it. So it's going to be 1/4 to the 5/2 power. Okay. Then once we're there, now we can break that down again. So 1/, this is a square root of 4, and we're going to take that to the 5th power. Okay, so really that is 1/2 to the 5th power. And we just said earlier on letter A there, 2 to the 5th power is 32. So this is 1/32. Okay. Okay. Cross your midline. Do something that turns your brain back on. I know it's been a little while. Okay, so simplifying with variables now. With this, basically what you're doing is you're taking something, this is your something, to a rational exponent, okay, to a fraction. That means both of these things have to be taken to that power. So really it's like saying 16 to the 3/4 power times y to the 8th to the 3/4 power. Okay, when we do that, we get this. So 16 to the 3/4 power is a 4th root of 16, and we're going to take that to the 3rd power. And now this, you're going to take 8 times 3 is 24 over 4, right? So rather than write this, you can write y to the 24/4, which is really 6, right? I'll write that for the next one. Okay, so keep going. A 4th root of 16. Anyone know what that is? It's 2. Okay, so we have 2 to the 3rd power times y to the 6th power, right? That's a 6. Keep going one step further. 2 to the 3rd is 8. Y to the 6th. Okay. All right, I'm going to do the next one with you, and then I'm going to have the sub pause the video and have you guys try C for a couple minutes, and then you can listen to how I did it. Okay, so letter B, let's do this one together. I typically would just flip it right away, right? It's to the negative 1/3 power. So I would go 1 over, and if you want to write it like this, I don't have to see this step from you. If you can kind of do that part in your head, that's okay. But it would look like this, okay? Now we're going to take this to the 1/3, and we're going to take 15 times a third. So it's 1 over 8 to the 1/3 power is a cube root of 8. And then 15 times 1/3 is x to the 5th. So simplify that. That's 1 over a cube root of 8 is 2. X to the 5th we can't do anything else with. So that is your answer. Okay, so let's go ahead and pause the video real quick. And then try it on letter C here. See what you get. Talk to your neighbor. See what they get. See if you're getting the same thing. And then you can start the video up again and we'll go through it. Okay, so 64 to the 2/3 power and x to the 4th to the 2/3 power. So if you want to rewrite that, it would look like this. I'm fine if you do the multiplication right away. 4 times 2 is 8/3. Okay. So when we simplify that, we're saying Kenzie's playing Play-Doh right next to me, by the way. If you're hearing her grunting, she's making cheeseburgers out of Play-Doh. Okay. Oh, not cheeseburgers? Oh, an onion for the cheeseburgers. Yeah. Okay. So this is going to be a cube root of 64, and we're going to square that. And then this is going to stay just x to the 8/3. Whenever it's just the variable, we leave it as that rational exponent. We don't need to simplify it because you can't get a simpler number, right? This we can get a number from. This we can't. So we just leave it like that. Okay. But this part we're going to simplify. So we're going to take the cube root of 64, which is 4. And we're going to square that 4. So 4 squared is 16. And then it's x to the 8/3. Cool. So 16 times x to the 8/3. Okay. All right, last two. We're almost there. So close. This one, we're going to simplify. So it's x to the 2/3 power over y to the 1/4 power. And the whole thing is being taken to the 12th. And one more thing. You have a quiz on Thursday covering 6.1 to 6.4. You'll watch a review worksheet, me working through a review worksheet somewhat. Maybe I'll have you guys work on it together. Then you don't have to just sit and listen to me. I might give you an option. Either do it with a partner or watch my video on your own. We'll see. I don't know what that's going to look like yet, but you'll have a review worksheet. You'll take the quiz. So just make sure you're ready for 6.1 to 6.4 on Thursday. Okay, and I could not figure out what I was doing with the editing of the homework stuff at the beginning. So I am going to do a few homework problems over here at the end of the lesson. If you understood these, you're welcome to start working on the homework. But if you had questions from the homework yesterday, here are the 4 that I'm going to go over: 24, 28, 30, and 36. Okay. So number 24, you are going to FOIL. It's going to be your first, so 2 plus your outside, which is 2 times 3 or 6 rad 7, times your inside, which is a positive 1 rad 7, times your last, which is rad 7 times 3 rad 7. So that's 3, technically that's 3 rad 49. That's just a 7, right? 3 times 7. So you have 2 plus, this becomes 7 rad 7, plus 3 times 7, or 21. So that becomes 23, right? Add your whole numbers together, plus 7 rad 7. Okay, so that's number 24. Number 28, this is one that tends to get done wrong a lot, not because it's so hard, just because people forget. You're not allowed to just square this and square that. When it's a binomial squared, it's 2 rad 5 plus 3 rad 2, and we're multiplying that by 2 rad 5 plus 3 rad 2. So when we do this, we are going to FOIL again. So when we do the first, 2 times 2 is 4, 5 times 5, sorry, rad 5 times rad 5 is just going to be 5. So 4 times 5 is your first, okay? Your outside, this is going to be plus 2 times 3 is 6. Rad 5 times rad 2 is rad 10. Your inside is going to be this, the purple, 3 rad 2 times 2 rad 5 is 6 rad 10 again. And then your last is going to be 3 rad 2 times 3 rad 2. So 3 times 3 is 9. Rad 2 times rad 2 is 2, the square root of 4, which is 2. So you end up with 20 plus 6 rad 10 plus 6 rad 10 is 12 rad 10 plus 18. And then when you simplify that, 20 plus 18 is 38 plus 12 rad 10. Okay, so that's going to be your answer for number 28. Let's see where I put this stuff. Here we go. Okay, number 30. This looks terrible. I mean, it doesn't look terrible to me, but maybe to some of you it looks terrible. When you're multiplying conjugates, remember conjugates just means these symbols are opposites. Everything else about them is the same. So when you multiply conjugates, the shortcut is you take a squared and subtract b squared. Your a is this, your b is that. So a squared is 4 squared, and then b squared is 2 rad 3 squared. Now for this, you're allowed to distribute the 2 because there's no plus or minus in between our two terms, right? We're squaring that term. So take both pieces of that. So when you do that, you get 2 squared, or 4. So this is 16 for the 4 squared, minus 4 times the square root of 3 squared is the square root of 9. The square root of 9 is 3. So 16 minus 12 gets you 4. Okay, and then last one is over here. Remember the rule on this. This is number 36. You are multiplying by the conjugate over itself of your denominator. So if it's 2 minus 2 rad 8, sorry, it's so pixelated, we're going to do 2 plus 2 rad 8 on top and bottom. Okay, so now let's FOIL this. 3 times 2 is 6. 3 times 2 rad 8 is 6 rad 8. Then your inside is 2 rad 8. And your last is 2 times rad 8 times rad 8. So 2 times rad 64, or you can just right off the bat there say 2 times 8. So this becomes, this first of all, 2 times rad 64 is 16. So you have 6 plus 16, so that's 22, plus 6 rad 8 plus 2 rad 8 is going to be 8 rad 8. Okay, now it seems like, oh good, that's our numerator. But rad 8 is not simplest radical form. We can break that into rad 4 and rad 2. So we would say 22 plus, this is 8 times 2, so 16 times that rad 2. Okay, so that's your numerator. Then your denominator, okay, flip that or put that on the bottom, you can use the shortcut for. So it's a squared minus b squared, right? So it's 2 squared minus 2 rad 8 squared. So we're going to distribute that. This is going to be 4 minus 4 times 8, or 32. So 4 minus 32, that's a negative 28. And now from here, there's a little bit of reducing you can do. All of these are divisible by 2. So we're going to do that. We're going to call this 11 plus 8 rad 2 over a negative 14. And that, my friends, is your simplest answer. Okay? Again, use the people in the room with you. If there's something you have a question on, ask someone around you. There's plenty of people in there who have a good grasp on what they're doing. Okay?